Determine a polynomial function with degree 3 that has a 0 at x equals negative 3 halves and a 0 at x equals 2 plus square root 5. Write the function in factored form and expanded form using only integers. Let's first list out all of the zeros, each of which have multiplicity 1. We have a 0 of x equals negative 3 halves, as well as a 0 of x equals 2 plus square root 5. Irrational zeros always come in pairs, in this case in the form of a plus or minus square root b, which indicates if 2 plus square root 5 is an irrational 0, then so is x equals 2 minus square root 5. And if we let a equal the leading coefficient, we can write the polynomial function f of x as f of x equals a times the quantity x minus the 0 of negative 3 halves times the quantity x minus the 0 of 2 plus square root 5 and times the quantity x minus the 0 of 2 minus square root 5. Notice there is no condition on the leading coefficient a, and therefore there would be an infinite number of polynomials that would satisfy the given conditions. For the next step, though, to express the factored form using integers, we need to multiply these last two factors. Let's work this out on the side. We have x minus the quantity 2 plus square root 5 times x minus the quantity 2 minus square root 5. Multiplying, we have x times x, which is x squared. And then we have x times the opposite of the quantity 2 minus square root 5, which is minus x times the quantity 2 minus square root 5. And then we have minus x times the quantity 2 plus square root 5. And then finally we have plus the quantity 2 plus square root 5 times the quantity 2 minus square root 5. And now let's begin to simplify. We have x squared minus 2x plus square root 5x, and then minus 2x minus square root 5x. And now for this last product, we have four products, 1, 2, 3, and 4. We have plus 2 times 2, which is 4. And then we have minus 2 square root 5 plus 2 square root 5, which is 0. And then we have square root 5 times negative square root 5, which is negative square root 25, or negative 5, giving us minus 5. Simplifying, square root 5x minus square root 5x is 0. We have x squared minus 4x, and then 4 minus 5 is negative 1, giving us minus 1. Going back over to the polynomial, we have f of x equals, notice this first binomial factor simplifies to x plus 3 halves. To clear the denominator from the fraction, let's let a equal positive 2. Again, a can be any integer, but I'm letting a equal positive 2 to eliminate the fraction from the factor of x plus 3 halves. And we know the product of these last two factors is now x squared minus 4x minus 1. Let's go ahead and distribute the 2. The factored form is 2x plus 3 times the quantity x squared minus 4x minus 1. This would be one possible factored form for a polynomial with the given conditions. And now for expanded form, we need to multiply these two factors. And again, let's do this on the side. This time we have 6 products. We distribute 2x and then 3. We have 2x cubed minus 8x squared minus 2x plus 3x squared minus 12x and minus 3. Combining like terms, we have 2x cubed negative 8x squared plus 3x squared is minus 5x squared. And negative 2x minus 12x is minus 14x minus 3. The same polynomial function in expanded form is 2x cubed minus 5x squared minus 14x minus 3. I hope you found this helpful.